Hey, what's up guys? Welcome to my channel. In this tutorial, we're going to be discussing and doing the house price prediction data science project. But this video will cover everything about the exploratory data analysis. We're going to go over concepts such as data observation, multivariate analysis, univariate analysis, filling in missing columns, adding outliers, and many more. Guys, before going further, don't forget to like, subscribe, and turn on the notification bell. You'll be the first to be notified when I upload new coding videos. Okay, guys, without further ado, let's go. Okay, the goal of this house price prediction data science project is for us to use different variables so that the air quality of the area, crime rate of the area, and other features to determine the value or price of a given house in a specific location. Okay, the first step which we are going to be going over, we're going to be importing our required libraries as usual. Okay, and importing weird right this. Okay, go to be importing Ibon as SNS for plotting. We're going to be importing mat.deep.pyplot PLT. We're going to import pandas, very powerful data science library in Python, as PD. We're going to import numerical library numpy as okay. I think this is all we'll be needing for now. Let's import it. So we'll be getting our data. To get our data, I'll place a link in the description below that will take you to my GitHub account where you can download both the data and the data for this data science project, the house prediction data, and also the notebook for this video. Okay, I've already downloaded mine already. When you download yours, you're just given only one data, which is the house prediction data. Okay, now I'm going to be reading my data, my pandas pd dot. Let's take a view of our data, the house wise. Okay, dot csv. Okay, let me run this now. Let me check the head of our data, overview of it. Okay, here you can see what I was telling you guys about. All what we are going to be doing, these are our data. I'm going to be using all these features, all these are independent features, just as my crime rate, my resident, the location, the region, the quality of the region, the room number, average number of rooms in the region, the age of the building, distance from employment hub 1, distance from employment hub 2, and teachers, airports, number of hospital beds, NOT rooms, number of hotel rooms, water body, rainfall in centimeter, bus terminal if present or not, and the parks. Okay, this is what we are going to be using to predict the value of this my house here in the location. Okay, now we're going to dive deeper into this data observation. Just actually check for the info. Let's check for the info. Let's see a overview of it. You can see here most of our value here are already in already numerical, already in float. Okay, except this one here. This one is airport, is an object, it's a categorical data. Also this my water body and also my bus terminal. Okay, and also you can also see some missing missing rows in columns of this data frame, such as this my number of hospital beds. We have about 8 missing rows in this column, number of hospital beds. Okay, so that's all we are going to be doing in this video. I'm going to be using all these features provided here to determine the price of the house. Okay, the next expression data analysis stage we're going to be going over is univariate analysis. Okay, univariate analysis. Okay, This analysis is simply analysis of each of features. In this analysis, no relationship or correlation is observed among the rest column. Only a particular column is analyzed. Okay. To do our univariate analysis, we're going to be using a dist plot. We're going to be plotting histogram of all these features in a single box. To do that, I simply call df.hist, my data frame.hist. I'm going to call my number of bins. I'm going to place it as 15. Then color, I'll place it as red. So be string red. Setting red color as black. Okay. Then line it. I'm going to just be one. Take it down. Is bigger size. This as 8. And the bill size so as 8. Then I want to know the grid. I want to see grid in my histogram. Okay. I'm going to give it a tight layout. Tight. I'm sorry. That layout. Setting the rect to 0, 0, 1 and 2, 1 and 2, and also 2. Okay. Okay. I think I should give it a line here. Then I'm going to call plt dot the subtitle of this house price shown in various lot. Then x, I'm putting x will be 0.65, y putting y axis should be 1.25. So go down here. Then all what I'm doing here is to just set to plot the histogram for the univariate analysis. I'm going to set font size to, okay, and it should be enough. Let me run this now. Let me see our plot. Okay, here you can see our plots. Wow. Let's see, let me zoom out. Let's see our plot here. This is the univariate analysis of all our columns, of each of our column in our past prediction data set. Let's see here. This is our price. This is for our, you can see this, it has a normal distribution. This is for our crime rate, somehow right skewed, our resident area, our hair quality, our womb norm, also normal distribution, our age, which is left skewed, this one right skewed, this two, and so on, so forth. You can see here our hair not room. From our observation here, you can see it has an outlier. That's the important of univariate analysis. It allows you to analyze each of the row. You can see here, this our hair not room may have some outliers here. You can see here, and also this our rainfall here. So we're going to be getting that later on in this video. So our next stage of expression data analysis is the multivariate analysis. In the multivariate analysis, we analyze how each column affects one another in the data set. We're going to be analyzing how our columns here, our crime rate, resident area, air quality, womb norm affect this our price in this our data set. That's the main aim of multivariate analysis, how each of them affects each other, the relationship or correlation between each of them. Let me name this variate analysis. Just to mark down. Okay. It's now. I think they should be together. Okay. So okay, the plot which we are going to be using for this our multivariate analysis is going to be the heat map. Okay. It's a very useful plot for multivariate analysis, which is going to show the relationship between variables and features in our data. To do the heat map, we're going to be creating a table first of correlation. Okay. Here's the code. Okay. And this now. You can see my table. Okay. Let me run this. You can see my table here, my table of correlation here. You can see it. How all these features, crime rates, residue area, room norm, and other features affect my crime rate. You can see here the feature that affect my crime rate the most here is the have high positive correlation is the room norm. The higher the number of rooms in the house, the greater the price. You can see here, and also my distance. And also, if you notice here, you can see here that my this one, my this two, and my this three, and my this four, all of them have nearly same correlation. So we're going to be discussing how we're going to be doing this later, maybe to find an average distance for all these distance here. Okay, so we don't want to create a dimensionality because we have a lot of features of variable in our data taking longer to fit. So also these teachers here, meaning the higher the number of teachers in the geographical region or the region, the greater the price of the house. Okay, value of the house. You can see here. I think those are just the ones that have high positive correlation, while the one that have the high negative correlation, meaning the higher the feature, the lower the price of the house. We have features like the proportion of poor people in the area, meaning the higher the proportion of poor people in the area, the lower the value of the house. Okay, and also this crime rate here, meaning if there's high crime rate in the region, the price of the house is going to be reduced, and also this residue area and air quality and age of the apartment. To visualize this a lot better, I want to be using this heat map, as I said before. We're going to call SNS.heat map. I want to be able to plot the heat map. Okay, let me set my fixed size. Okay, equal fixed size should be equal to 10 by 8. Okay, then my heat map should be my correlation plot, this plot here. Then let me set a note to true. Okay, what about opposing the two decimal place? I'm setting the FMT two decimal places. Don't want all these values to be in our two boxes. So I'm going to set the code one, the color map. Or then line width 0.2. Okay, so let me set the title the last. I'm going to be doing this heat map house wise more multivariate plot. Then my font size should be 12. Okay, let me run this now. Let's see our plot. What do you see? Okay, let me actually change this. I think this isn't supposed to be a string. Let me this again. Okay, here we have our heat map here. You can see our heat map here. How beautiful is this? You can easily find the correlation between the plot. You can see here the major parameter that affect that positive correlation. As I said before, is this my room norm, and also my this my 51% okay teachers. Okay, and you can see here this this one, this two, this three, and this four. All of them have nearly same correlations. You can see 0.25, 0.25, 0.25, and 0.25. So we are going to be deciding on what to do later. Okay, the next stage of our exploratory data analysis is handling of outliers. Okay, Let me give my markdown. Okay. Handling outliers. Okay. And we want this. Okay. So to detect our outliers, this our univariate plot here will be really useful. Let me just, instead of me to write the code, let me just copy this code here and come down here and paste it here. Okay. Okay. This is our plot here. You can see here, guys, I can easily define those that have outliers. Like this crime rate now, it's looking like it has an outlier. So we're going to be detecting it using a very popular plot, the scatter plot, scatter, to verify if it has an outlier. Got df crime rate. I'm also going to plot it against our dependent variable, which is price of the house. Then color should be red. Okay, we want this now. Has no attribute scatter. Oh, it's supposed to be paired. I'm supposed to use paired thing. Okay, let me want this now. What's happening? Okay, let's say this my price. I think it's supposed to be a lowercase. Let me on it now. Okay, here you can see the distribution. Let me zoom it out. You can see the distribution of our plot. You can see here it isn't really an outlier. The distribution of data isn't. This distribution of data here isn't that far away from the rest, so it's not an outlier. What other column can one easily identify there's outlier? There's no outlier in my receipt area. Equality is clear. My room num is clear. Age is clear. This 1, this 2, this 3, and this 4. All of them are clear. Teachers is clear. My proportion of people is clear. Number of hospital beds is also clear. Then when I get to my room numbers, I'll see here we have there's high chance of outliers in this my room number of hotel rooms. So let me just confirm that here. Rooms. Okay, let me run this now. Okay. Here you can see here there's really an outlier. Inference was correct. You can see here there's outliers in our handout room. You can see the distribution of the data in this my handout room is really far away from these two. So these two are outliers. Okay. And also in this my let's check my range 4. There's high possibility of an outlier there also. Range 4. Let me run this now. Oh, you can see here we have just one outlier here, very far from the rest of the distribution of the data. Okay, I think those are the 2 outliers that we have. So I'm going to come here. Twice to mark down. I'm going to write observation. What is to write that observation? Okay, but add bias in handout rooms and also in range 4. Okay, let me run this now. Now see we have outliers in our handout rooms and range 4, which we are going to be handling later. To handle these outliers, we are going to be using the percentile method, which is a very powerful technique of detecting outliers. To do that, well, instead of us to keep writing it, we'll just create a function for it. Out as okay. We are setting the data frame and the code. Then I'm going to be setting the upper value factor to be 3 and the lower value factor 0.2. Okay, so we're going to be creating an upper limit. Should be uv should be equal to np dot percentile should be our df. It's our code here. Oh, sorry, should be code. Then the 99th percentile, that any value greater than this my 99 percentile multiplied by my UVF, which is 3, is considered to be an outlier, and also any value less than my first percentile. Okay, let me just call this, yes, my first percentile multiplied by LVF, which is 0.3, is also considered to be an outlier. Then I want my function to return formatted string. I'm going to call this upper limit is your grade. Okay, then my lower limit is LV. Okay, let me run this now, and let me test our function we just created. Test our function. We'll be testing in this our atlas in this one and out rooms. Let's show you. And okay. Then to get the outlier, I simply call my P outliers, my data frame, my colon, which is n odd. Okay. The factor is because I'm not going to be changed. Factor is default parameter, so I'm going to run this now. What is it telling us? P outliers is not fine. P outliers. I think I wanted it before, and now what's happening? Okay, this is a capital letter. Okay, just coming to a lowercase letter. Then I run this again. Okay, you can see here this is my upper limit 46, and my lower limit is 3.0. Okay, then I'm going to say any values greater than this my 46 is considered to be an upper outlier, while those less than this my lower limit, which is 3, is also considered to be a lower outlier. To do this, we're going to do df, okay, and what once, and I'm also going to come out to write give it a condition df.n what once, okay, greater than 46. Let me just see the values there. 19. Let me run this. And see, we have just two values, which are the one we saw earlier. Those two values are 101 and 81. I'm going to be filling it with the mean. I'm going to fill them with the mean. Also, we're going to say any values greater than is my 46.19 should be equal to my df dot n dot ones dot mean. I'll fill it any value, but me I decided to fill it with the mean. Okay, let me run this now again. Then okay, let me just copy this code. Let me see if it's still there. Okay, this again. I see here there's no more atlas in this my n outcomes again. See here. So the next column that is atlas is this my rainfall. I'm going to call in now. I'm going to type rainfall. Then I'm going to call my p outlier. Colon my data frame as usual. Then my colon is rainfall. Let me run this. Still happening again. Say okay. So be honest here. I don't know why I keep making same mistake. Let me run this again. As you can see, my upper limit is 180. So any values less, my upper limit is 180, while my lower limit is 6. Any values greater than my upper limit, which 180 is considered to be an outlier, and those less than this my 6 is also considered to be an outlier. Okay, so I'm going to come down here, and also from our inference and our scatter plot we plotted, you can see here that there's only a chance of us having a lower outlier, so we're only going to be detecting for the lower outlier. I'm going to say df rainfall I did before, df dot rainfall less than, this is my 6th year. May run it now. I see we just have one value, which is this one here. Just one value, which is this 3. And see the value is 3. I want to also be replacing it with the mean also of the data. df dot and for okay. Let me run this now. Okay. And then we call this, and you can see here that, so you can see that the outlier is gone already on this. You can see here now we don't look at outliers in our data anymore. So the next step of data preprocessing we're going to be going over is going to be filling of the missing rows in our column. Call this filling missing cross columns. Okay, run this now. Okay, let me call my df.info that I called before. I think we have just one column that is missing value. Last here we just have just one missing column, which is this number of hospital beds. So we're going to be filling it. To fill it, I simply call here and use my pandas extension method. df.n bed. See beds, okay. Beds should be equal to my df.n beds dot fin. I'm going to do my final function. Okay. And also I'm going to be filling it with the mean df.n beds dot the mean for our data. Let me run this now. Okay, when I run this again, okay, you can see here my n bed has been filled. There's no longer missing column, missing rows in my data. As I told you guys before, we're going to be doing something about this this 1, this 2, and this 3, and this 4. I want to find the average distance. Okay, I'm going to be creating an average distance column, a new column called average distance, called average dist. I'm going to set it to be the average distance of this our board distances. I'm going to say df dot dist 1 plus df dot dist so plus df dot 3 plus df dot dist. Okay, then we're going to be dividing by 4 since we have 4 values there. So let me run this now, and let me call my df.info again. Here you can see our average distance has been created, so we will not be having any use for these distances again. So I will be deleting this, this 1, this 2, this 3, and this 4. I'm going to call df 1. Let me just copy this, and so I don't have to be tapping this again. This, and just change this to 2, 3, and 4. Let me run this now. Okay, and let me call my column, my data info again, and you can see all those this 1, this 2, this 3 has been deleted and replaced with my average distance. Okay, the next stage of my exploratory data analysis is handling of categorical data. Handling categorical data. Okay, we want this. Okay, to handle our categorical data, first of all, I want to be checking for their unique values. As you see here, we just have about 1, 2, and 3. We just have 3 categorical column in our data, which is the airport, water body, and bus terminals. So we're going to check for their unique values. so that in case if their unique value is very high, we are not going to be using this. We are just going to delete them to avoid dimensionality cost, because we are going to be using one hot encoding method to handle our categorical data. So I'm going to call df dot our airport unique. This will give us the unique values there. Let me run this and see. We just have 2 unique values here, so this one is good to go. We're going to be handling this using one hot encoding method, and also show other one again, my water body on this again. Okay, you can see here my water body, we have the river, lake, non the river. So we're also going to be adding this using one of the encoding method, and the last, which is my bus terminal. Let me check how many unique values here. My bus terminal. Everyone, this, as you can see here, we just have 1 unique value, and I don't think this is going to have any correlation with the value of the house. So I'm going to be deleting it, because I mean, if it's just 1 value, it's not going to be having other effects. So I'm just going to delete it. Do this. I'm going to call df bus down. And also, if your data have just 1 unique value, it's always advisable to delete it, just to reduce the number of columns, so that you can reduce the number of columns in your data set to be the most important column that have the highest correlation to your target or dependent column. Okay, I'm also using here if you go to pd get documents. If you don't understand one on encoding, I will place a link in the description below, so you can go check out my other videos about one hot encoding method. I created the video where I taught everything about one hot encoding method. And called df, then the columns. It's going to be just these 2 columns, which is airport and water body. Okay, let me run this now, and let me call my df on this now. See here now, just go ahead. Okay, you can see here now, this is our data frame now. After one hot encoding the categorical columns, you can see airport no, airport yes, water body lake and river, water body none, water body river. Okay, well, if you can't understand this, my categorical column here, you can see here that it is having too much column. Like in this my airport yes and no, it can only be 1, meaning if it's yes, it means it is present, and if it's no, it means it is absent. Meaning anywhere this my airport yes is equal to 1, it automatically means my airport no is going to be 0. Okay, meaning if my airport is present, I mean, it's not going to also be absent at the same time. So I'm going to be deleting this my airport no also, just to minimize and reduce my column to the most important columns. I'm going to be deleting, okay, or there df, right, which is but no, capital letter on this. Then also for my water body, there won't be any need for this none, because if all of them here are 0, 0, 1, it will automatically mean this one is going to be 0, meaning anywhere there's 1 here, there's going to be a 0 here. So my water body none is going to also be deleted. Delete my water body none. What time? There's no body. No, okay. on this time. Let me call my data frame again. Check the head. And here you can see here our preprocessed data frame. We already run exploratory data analysis on it. Already run it. Here now our data set is ready for fitting to our machine learning model. In the next video, guys, I'll be creating machine learning model to fit this our preprocessed data set. I'll be creating a separate video for that. Now I'll placing it in a link in the description below. Don't forget to check it out. Thanks for watching my video. And if you're not subscribed to my channel yet, don't forget to subscribe, because I'll be releasing video about data science project, machine learning, and Python programming language on a regular basis. Okay guys, thanks for watching.